Now, let's start with chapter 2. Chapter 2, we only talk about aqueous solutions. We only talk about aqueous solutions. How compounds dissolve in aqueous solutions. Compounds can be ionic or molecular. Yes, we have studied that before. We have ionic compounds and molecular compounds, or we name them covalent compounds. Ionic compounds, ionic compounds are held together by ionic bonds. So ionic compounds, ionic bonds. But molecular compounds are held by covalent bonds. So this is number 2. So covalent compounds with covalent bond, of course. Ionic compounds, ionic bond. When they dissolve in water and separate into ions, when they dissolve in water and they form ions, become ions, ionic compounds and molecular compounds behave differently. Kate, اتوانوا زور جاوزن. How do you shape that? So what does that behave differently mean? We'll try to step by step explain those things. It says ionic compound doesn't need action of water, but molecular compound does. I think this sentence is not in your book, but in the booklet, please try to underline it or highlight it, because after a while, when you understand it, when you come back to study it, that like that thing or that sentence can be asked in questions or in exams. Let's talk about the first term. This term is very important. Dissociation. Sometimes, most in the most places or sources, when I try to find pronunciation of dissociation, they call dissociation. But there are also sources, or I have seen it in dictionaries, that also can be read as dissociation. There isn't any difference. It's up to you. But I think for me, it's easier to say dissociation. Then what is dissociation? Is separation of ions that occurs when an ionic compound dissolves. So when an ionic compound is dissolved in water, what happens? Separation. This word is important. Separation. جابونه بس. But when ionic compounds dissolve, let's say in water, I think you can add that also in H2O. This is called dissociation. For example, NaCl. When NaCl dissolves in water, see, this point here, H2O, means the solvent is water. And it's just helping the solute, the substance, to get separated. NaCl can be separated in H2O to become Na and Cl. How many Na do you have here? One Na. How many Cl? One Cl. So when they separate, both of them become one. Don't look at the moles for now. Let's just look at how they are separated. All right. Na2SO4, when they separate, they become C2Na. 2Na. That 2, where did that 2 come from? It's from the sulfate. But we only have one sulfate, everyone. So in order to be successful in this chapter, or to understand this chapter and easily solve the questions, you have to memorize the last year's tables. Monatomic ions and polyatomic ions. I have added those tables in the new booklet here. So this is the new booklet. What are the pages? I don't remember the pages, but somehow these are the pages. So these two tables, they are very, very important for you to memorize them again. Even if you have memorized it now, until now, please try in these couple of days or in this week, try to memorize them, because it's very hard to solve questions without this. If you don't know how to convert a name into the formula or formula back to the name, it's going to be a problem.
ماسەبێت چارجوشتەکانی لە بەرکەیان چ شتێکی
بەڵێ کێشە یعنی لە سیمبل و چارجەکەی تۆ بزانی کۆمپاوندەکە چییە، چۆن بزانی فۆرمولەکە نووسی. For example, let's go back to our thing here. When it says sodium chloride, you have to know it's NaCl. Or when it says sodium sulfate, like this, for example, sodium is positive 1, you will say, oh, what is sulfate? It's SO4 with 2 negative. The whole SO4, we look at the whole SO4 as a 1 unit. And then when this 2 comes in front of the Na, and this 1 comes in front of the SO4, it becomes Na. The 2 comes here, 2. The whole SO4 stays the same as SO4. So when you separate it, it goes back to the same thing. It becomes Na and SO4. But if the charges are different, we have 2 Na. That's why the coefficient of Na, the balancing of Na, becomes 2. We call those numbers as coefficients. Now, what if there is a change, or we want to find the moles? Again, last year in chapter 3 of geometry, it talks about that in an equation. If you know the mole of only one of them, you could have found the mole of all of the other substances. Let's say there will be one. NaCl, if NaCl is 1 mole, so that is if. What would be the mole of Na? We have to look at the coefficient. What is the coefficient of NaCl? 1. What is the coefficient of NaCl? 1. Then what is the coefficient of Na? Again 1. So if two things have the same coefficients, it means that they have the same mole. So if this is 1 mole, this also must be 1 mole. What is the coefficient of Cl? It's again 1. Then mole of Cl is also 1. So that's how you can say this. When NaCl dissolves in water, it separates into ions. If we ask how many moles of ions are produced, you'll say 1 mole of Na, 1 mole of Cl. And together, the total is what? 2 moles. Let's look at that in example. Na2CSO4 has been separated to what? 2 Na and 1 SO4. 2 Na and 1 SO4. So if Na2SO4, which has a coefficient is 0.5 mole. See, the coefficient is 1. Then Na, which has 2, it must be twice as much as the Na2SO4. Then, where did this 1 come from? 0.5 times 2, which is equal to 1. But since SO4 is still 1, and this is also 1, so these two must have the same mole. That's why both of them are 0.5. The other is 1.5. Another example, an easier one, so that you can see how can I solve this. Let's say I'm gonna write magnesium chloride. In the exam, when you see magnesium chloride, you have to know what is the coefficient of magnesium chloride. It is Mg is 2 plus, and with Cl, which is -1, the 2 comes here, so it becomes MgCl2. Now let's write that down. MgCl2, when dissolves in water, it becomes 1 Mg, C1 Mg, and how many Cls? 2 Cls. So when we change the states, we change from solid to aqueous. This is solid. The ions are aqueous. They become aqueous. Now, if MgCl2, let's say, is 0.6 moles of MgCl2. How many moles of MgCl2, or like how many moles, 0.6 mole of MgCl2 will produce? How many moles of iron it will produce? Here's what you're going to look at. Coefficient here is 1. Coefficient here is also 1. So these two must have the same mole. This is also 0.6. But for the Cl, which has a coefficient of 2, it must have twice as much of mole as MgCl2 or as Mg. كواتا مادام Cl coefficient دکی دو به دو اوانه MgCl2 ده. بوی 2 times 0.6 equals to 1.2 moles. So we have 1.2 mole of Cl negative and 0.6 mole of Mg. Together, total, we have 1.2 plus 0.6, we have 1.8 total mole of ions. So we have a total of 1.8 moles of ions. All right. Another example, like the sample problem here. It says we have a compound aluminum sulfide. In this question, the formula is also given, but not always the formula will be given. So what is aluminum sulfate? Al2SO4. Al2SO4 by 3. When we separate them in H2O, they become how many aluminiums? 2. But this one is solid. They become aqueous, solid. How many moles of sulfate? See, sulfate, nitrate. The ones like here, like this one, in second table. We look at these, for example, bromate, acetate. We use them as one unit. Because when you say bromate, bromate means 1 Br and 3 oxygens together. BrO3. You don't separate that. It remains the same. When it says nitrate, it means that it's 1 N and 3 oxygens. All right. Now we have 3 sulfates. This is also aqueous. عاوش دوباره وضع aqueous بتوعته. Now it says if it's 1 mole, what would be the mole of aluminium? If this is 1 mole, what is the coefficient of this? 2. What is the coefficient of this? 1. 1 for 1. Then 2 must be times 1. So 2 more. What if this one is 3? So 3 times 1 mole, we get 3 mole of ions. And both of them together, total, we have 5 mole of ions. كانت معناها كنز معناها. Let's say for the same compound, I'm going to write another number. What if aluminium sulfate is 0.2 moles? Then multiply by 2. 2 times 0.2, we get 4.4. So sulfate, 3 times 0.2 will be 0.6. And a total of 0.4 and 0.6 total 1 mole of ions. geçtim بابا هسه بسيتش معنى انش فلكي ليرة چی معنى بس جابونو معنى كجابتو تو بس وانا سيد كبزانا چند دانه تياب بالانسكي بنوصل طول ويلي قدام تانا بيه قب تانا بينس you have to know what is ammonium chloride. So it's NH4 plus, chloride is negative. So both of them together becomes NH4Cl. Now, NH4, this is A, NH4Cl, when it dissolves in water becomes NH4 and Cl. What is the mole of NH4Cl? It says if it's 1 mole. Then, what would be the mole of NH4? It has one coefficient. This one also has one coefficient. So it becomes 1 mole. This one is also 1 mole. So total 2 mole ion my day. B. Let's solve B. Sodium sulfide, Na. Sulfide is 2 negative. The 2 comes in front of the Na, the 1 gets here. So what is produced? Na2S. See, that's why I told you you have to know the tables. If not, you probably not, cannot figure out the formula of, for example, sodium sulfide. Then Na2 sulfide or Na2S, when it dissolves in water, it becomes how many Na? 2 Nas with only 1 sulfide. Again, what is the mole? Here is 1 mole. So this must be 2 moles. This is also 1 mole. And together they form 3 mole of ions total. All right. C. Barium nitrate. Now, barium is 2 plus. Nitrate is negative. Together, the 2 gets in front of the C. In that case, Ba, which is 1 here, the 1 gets here, not a problem. NO3. This 3 is connected with the oxygen. So when you put the 2 in front of the 3, you can, like, it must be for all of them. It's not only for the oxygen. It's not only for the nitrogen. It's for all of it together. That's why we look at it as one unit. We have to put what? A bracket between the NO3 so that, or around the NO3 so that we can put this 2. Because when it says 2 what? 2 nitrates, 2 NO3s. How do NO3 peko? Boku yok unit seriyakin. Kalın barium. That's why it is barium nitrate 2. When it dissolves in H2O, becomes barium, and 2 nitrates can be taken out from this compound. Again, look at the moles. This one is 0.5 mole. And barium is What is barium? Coefficient of 1, coefficient of 1. So it means that it is the same. It is 0.5 again. 0.5. What about this one? 2 times 0.5 mole, we get only 1 mole. And all of it together, 1.5 mole of ions. That's the whole. The most important thing here, so that you can easily solve all of these questions, are the two tables. You have to know the ions, you have to recognize the charges, what are the symbols. Because I will tell you that in ministry exam question, even though this subject is very easy, but they will write different things. Sometimes if you don't remember what's the symbol, what is the charge, maybe they will change the charge. They will give you a wrong charge. At that point, you wouldn't be sure if you don't know the tables.